Okay, so in this video, I'm going to attempt to show you another a difficult mechanism here. So this is kind of like this is a dehydration reaction, but it's kind of a ring opening, ring closing kind of mechanism. And it's, again, depending on how, and depending on whether your instructor's in a bad mood the day he's writing the exam, sometimes this tends to get, sometimes this tends to get asked on the free response organic chemistry exams. Again, this is probably is more applicable for maybe chemistry majors. They might see something as of this difficulty, but you just never know. Just depending on the university you're at, you might see this in just a regular organic chemistry course. So I just really wanted to show you all how to best go about solving this problem, because depending on the university you're at, you might see something like this on a free response organic chemistry exam. So I'm going to go ahead and start and show you where you would begin in this occasion here. All right, so we have here we have 2,2,1 trimethyl cyclohexanol, and so again, first step is, so you protonate your starting material. So by now we should all know that first step is always, first step is always protonation. So I have HOSO3H here, or H2SO4, same thing. And I'm going to protonate. These electrons jump on oxygen, so always write your arrows like that. And what do you get from that? You get a protonated hydroxyl, in other words, hydronium here. Okay, so that is what you get. So next thing that happens is this is a good leaving group now, so it leaves, right? So it leaves. And so, the electrons from this bond here jump on oxygen, and you form, I'm going to write it out here, you form this carbocation right there on that carbon. All right, so I'm going to go ahead and jump to the next slide because I'm running out of space here, and I'm going to show you all what happens here. So I'm going to write this in black. So this is our carbocation, right? So what happens here? So this is the tricky part. All right, so I'm going to label these before I get started here. I'm going to label these carbon. I'm going to label these in blue. I'm going to label these carbon A. That's my carbon A. So this carbon right here is carbon A. That carbon here is carbon B. And this carbon right here is carbon C. Okay, and I'm going to show you all what happens. So the electrons from this carbon bond between carbon A and carbon B are going to attack carbon C. So these electrons here are going to attack that carbon there. So what you're doing is you're forming a bond between carbon A and carbon C. So you're forming a bond between carbon A and carbon C, which means the bond between carbon A and carbon B is breaking. So that bond has broken, and you formed a new bond between carbon A and carbon C, and it's going to make carbon B, along with its two methyl groups, it's going to flip over. So it's going to whip around, and you're going to get something like this. So remember, we're forming a bond, we're breaking the bond between carbon A and B, and we're forming a new bond between carbon A and carbon C. So we're getting something like this. Again, on carbon C, you have a methyl group, and then the bond between the bond between carbon B and carbon C whips around, and you form that right there, just like that. So just to keep track of our carbons here, this is carbon B, right? This is carbon C, and this is carbon A. Awesome. Good job, y'all. I know that's a little crazy, but that's essentially what happens. And then, so we still have to keep track of our carbocation. You can't lose your carbocation. Where did your carbocation go? You can't just, excuse me, you can't just draw this and be over, have it over and done with. So where did your carbocation go? Again, let's look at carbon A again over here on the left again really quickly. So carbon A had 4 bonds, right? Had 2 hydrogens on it. And those are still present. However, carbon B had 2 methyl groups. It has 2 carbons attached to it in the form of 2 methyl groups. So carbon B is the one that lost the bond. So because of that, that's where your carbocation goes. Okay, that's where your carbocation goes. So carbon B is the one that lost the bond. So there's your carbocation. Okay, and so we're almost really close to our final product. So before we get there, we have one more step. So I'm going to go back to the previous slide and show you all your final product. So the final product here, the final product looks something like this. So how do we get from what we had here on our intermediate? How do we get from that to that? So how does that happen? And again, on an exam, they wouldn't ask you to predict that this happens. Typically, they're going to show you. They're going to show you the final product. So they're going to show you that you get this, and they're going to ask you to draw the stepwise mechanism. They're going to ask you to draw the mechanism on how that happened, on how that occurred. They're not going to ask you to predict this product. Professors aren't that crazy. They'll always give you the product, and they'll ask you, okay, give me the mechanism. Show me how we got there. And so we're almost close. We're really close. One more thing we have to do is, so again, going back to this slide, do you all see how we have 3 methyl groups? We have 3 methyl groups there. We have 3 methyl groups on carbon B. All right, so how did that happen? How did we get 3 methyl groups there? So that must mean that we get a methyl shift. So this methyl group is going to shift onto carbon B, and that's how that happens. So that's called, remember, that's called a methyl shift. So methyl shift. And that's how that happens. So there we go. Now we have created here what we wanted. And now we have the carbocation right there. So that's exactly what we wanted. So just let's go ahead and look back at the slide over here. As you all can tell, that's exactly what we wanted. That's the intermediate that we needed, because now we can easily, remember in the previous step we made HSO4 minus, and that's our conjugate base, and so that's just going to steal one of the hydrogens from the adjacent carbon here, and these electrons are going to collapse right there, and you're going to form your final product, which is exactly what we were trying to get. There you go. So that's how you form the final product here. That's how you get that ring closure. So again, this was just this is classically asked on exams, just depending on the level of difficulty of your course. Just don't be surprised if you see this. So that's why I just wanted to go over it with you in case you were to see this on an exam, because I certainly did when I took organic chemistry in undergraduate. So again, thank you very much for watching. Stay tuned for the next video.